Okay, here's a couple of examples of vectors questions which involve parallelograms. I've put the example there because I thought you could probably pause it and copy it down rather than me actually sort of write it and talk. So we've got three vertices A, B and C of a parallelogram A, B, C, D. Just note this parallelogram A, B, C, D, it needs to go around in order, so it needs to go A, B, C, D. So that puts D over here somewhere, and we want to find the coordinates of D, and we want to work with vectors because it's a vectors question. So I totally take on board that you could just look at the coordinates and work it out. But if you're working with vectors, you travel along vectors. So we're going from the origin to A, and then we're going from A to D. And the result of this, sorry about the smudging, is that you get the position vector of D, which is OD. So O to D is equal to OA plus AD because it's a parallelogram. AD is the same as BC. And the vector that takes you from B to C is equal to the position vector of C minus the position vector of B. So 1 plus 2 is 3. 7 minus 1 is 6. So to get from O to D, we go from O to A, which is 6 minus 2, plus BC, which is 3, 6. And that puts D, position vector of D, at 9, 4. So the coordinates of D are 9, 4. So always remember to change your position vector into coordinates. So that's approaching that as a vectors question. Second example is here. So we've got parallelogram U, V, W, X. This length here is 8b. This vector here is 3a, and then that would make xw 3a as well. And y splits vw in the ratio of 3 to 1, and xz is 4/3 of xw. So we want to prove that u, y and z are collinear. What this means is that if they are collinear, u, y and z will all lie on the same straight line. So what we can do is basically prove that uy and uz are parallel vectors, and if you have two parallel vectors with a point in common, then these 3 points must be collinear. So I can start by looking at how to get from u to y. So we need to travel along known vectors. So uv plus vy. uv is equal to 3a. And then vy, this is splitting vw in the ratio of 3 to 1, so 3 parts to 1 part, so it's 3/4 of the way along vw. We know that vw is 8b, because it's a parallelogram. And then we end up with ui is equal to 3a plus 8 over 4 is 2 times 3 is 6b. Doing the same for uz. So this time I'm going along here, along here. So uz is ux plus xz. Ux is equal to 8b and xz is 4/3 of xw. And xw is 3a. So that makes uz 8b plus 4a. Actually, I'll write that around the other way so it's consistent with my other one. So that's equal to 4a plus 8b. So from here we can see that these two vectors are parallel. So uz is equal to ui divided by 3 and multiplied by 4. So it's equal to 4 over 3 ui. So that's how you show two vectors are parallel. So you show that they're scalar multiples of each other, and then they share a common point. So the point u lies on both vectors, and so therefore ui and z are parallel. So u is a common point, and so I think I might have said that wrong a minute ago. This implies that u, y and z are collinear. So two parallel vectors that share a common point are collinear vectors. So yeah, I hope that's clear. Any problems, of course, let me know. Thank you.